Hey there, I'm Austin Proctor and this is Lab 9, the video lab report. In the on-campus lab a few weeks ago we examined the motion of a spring mass system that oscillated vertically. There was no horizontal component to it, no x value. And what we're doing this time is we're examining the motion of a spring mass system where instead of just oscillating up and down, it also swings in an arc. So we're adding in the x component for this. And we'll start out with the tracker video that was given to us, and we'll play it from the beginning, or almost the beginning. As you can see, I moved the start slide to about 5 forward in order to start it from where he releases the spring. And as you can see, the calibration stick is set to 0.7 meters. The axis is to where that this is the negative y, and the origin is right here at the point that he told us to put it at. And as you can see, I've also tracked all the positions. Ended up being about 100 of them. So if you look over here, this is the x and y values, and we've taken that and put it in an Excel spreadsheet, and then from that we imported it as a CSV into the Python model, or into the Python program. And I'll go ahead and run that while I explain it. Here you can see the spring doing its work. And what we're doing here is comparing the computational model to the tracker video. And right here, the blue model represents the CSV info, while the orange represents the computational model. And we'll let that play through for a second. And as you can see, it's graphing the coordinates. And here we go. It should be about done by now. One more time around. And there it goes. So, if we'll come back over here to the computer stuff, the model, and as you can see, we have the if you scroll down a little bit, we have all of the information, the spring stiffness, force of gravity, L naught, the force, L hat, force of the spring, all of that is in here. And if you look at the bottom, we have printed out the work, which we'll get to in a minute, but that comes out to be 0 point, it's a very small number. As you can see, it's to the, I believe that's the 10,000th value, so very small, basically 0. And if we move over here to the what does it mean questions, the first one says, compare the period of oscillation you found from examining the x component of position with the period of oscillation determined from the y component of position. And as you can see, they do differ, and they are independent of each other. So with number 2, it says, with your new choice of system, determine the work done by the surroundings. And since it's all the same system, no work is done, and that explains the energy principle. And then number 3, when defining the gravitational potential energy in your computer model, you made a choice for the location of the origin. And if we change the origin, we will see by going here that the physics, it does not change the physics, it just changes the orientation of the kinetic and potential energy. But as I said, no physics has been altered. So that should answer all 3, and that should pretty much sum it up for Lab 9 video lab report. Thanks.